Alright, in this video we will do an example for naive Bayes to understand it better. So in this data set that is given to us, we have three features, F1, F2 and F3, and it is a classification problem, the kind of problem that we are familiar with in the course, where we have to predict either positive or negative class. It's also a binary classification problem. There are only two possible classes, positive and negative. Now this example somehow I've seen confuses students when they do the calculations, though it's very similar to the outlook rainy and humidity, the data set that we did for decision trees and naive Bayes. This problem is very similar to that, but the value here being a and it's repeating across the features, and that somehow confuses students and causes them to calculate this wrongly. So anyway, so let's look at how to solve this, and then hopefully this would become clear. Now we want to calculate for a test example where F1 is equal to A, F2 is equal to C, and F3 is equal to B. Right? So for that, first we calculate all the probabilities because we are required to show complete work. So we are going to start with probability of class is equal to plus. Now how many pluses are there? 2 out of 5. So probability of class equal to plus is 2 over 5, right? Now let's go into each feature and its value. Probability of feature 1 is equal to A given class equal to plus. Now how many are there where feature 1 is A and class is plus? So we have 1, feature 1 is equal to A, class is plus. There's another feature 1 equal to A, but class is minus, so we don't count this, right? And out of 2 pluses, we have one of them where feature 1 is A, so the value here is 1 by 2. Now probability of feature 1 is equal to A given class is equal to minus, right? So for minus, we have feature 1 equal to A, class equal to minus, but there are 3 minuses, so the value becomes 1 over 3, right? Probability of feature 1 is equal to B, class equal to plus is equal to, there are no B's where class is plus, right? There is only one B, but the class is minus. So we get 0. Then we have probability of feature 1 is equal to B, class equal to minus. So how many feature 1 equal to B when class is minus? 1 out of 3. right? Probability of feature 1 equal to C, class equal to plus, right? We are calculating them in order. We calculated feature 1 equal to A first, then B, then C, class equal to plus. C and plus, there is 1. There's another one where it's A. So this would be 1 by 2. Probability of feature 1 is equal to C plus equal to minus. 1 is equal to C, class is minus. There is one of those here. So this would be 1 over 3. Now let's go to probability of feature 2 is equal to A class equal to plus is equal to, now we are looking at feature 2. Now when we look at feature 2, we have 1 inside a plus, right? So this would be 1 by 2. Probability of F2 is equal to A class equal to minus. Now here we have 1 again, right, out of 3. So we have the value to be 1 by 3. Probability of F2 is equal to the next value. So is there a B in F2? There is no B. The values have only A's and C's. Now then we can go to C, the next possible value for F2. Class equal to plus. Now for F2 is equal to C, class equal to plus. There is one value out of 2 values, so the value is 1 by 2. Probability of F2 equal to C, class equal to minus. Now there are 2 of those values, right? Then we get 2 by 3. Now let's move on to F3 because F2 is complete. There are only 2 possible values. F3 is equal to A given class equal to plus. Now when F3 is A, class is plus, there is one value, so it's 1 by 3. Now probability of F3 is equal to A class equal to minus. Now there are 3 total number of values. There is only one where F3 is equal to A, that is 1 by 3. Sorry, the value F3 is equal to A, class equal to plus, that would be 1 by 2, right? Okay, so now we have probability of F3 is equal to B, class equal to plus. f3 is b. Is there an f3 equal to b in the training data? No. So this would be 0. Probability of f3 equal to b given class equal to minus. And there is one of these in 3. That would be 1 over 3. Probability of f3 equal to c given class equal to plus. Now there is 1 out of 2 values there, right? So it's 1 by 2. Probability of f3 equal to c given class equal to minus would be 1 out of 3 values, 1 over 3. Now we want to calculate for f1 is equal to a, f2 is equal to c, f3 is equal to b. And we want to calculate this for both the classes, right? So how do we do that? Probability of f1 equal to a given class equal to plus times probability of f2 equal to c given class equal to plus probability of f3 is equal to b given class equal to plus times probability of class equal to plus. Right, this is for the positive class. Now we can calculate this. f1 equal to a, class equal to plus is 1 by 2 times f2 equal to c, class equal to plus is another 1 by 2 times f3 equal to b, class equal to plus is actually 0 times class equal to plus 2 over 5. Because there is a 0 and we did not employ smoothing, we got a value of 0. Now to calculate the other one, probability of f1 equal to a, class equal to minus, probability of f2 equal to c, class equal to minus, probability of f3 equal to b, class equal to plus, sorry, class equal to minus, times probability of class equal to minus. Now this is equal to f1 equal to a, class equal to minus 1 over 3 times f2 equal to c, class equal to minus 2 over 3 times f3 equal to b, class equal to minus 1 over 3 times fp of class equal to minus. Class equal to minus is 1 minus class equal to plus. is 3 over 5. Right? Now, multiplying this, we can see just by looking at the numbers that this is greater than 0. So the final prediction would be minus. And this is, you don't have to go through all of these calculations. Only the required ones are enough. I just went through all of them to show all the entire work here. In order to calculate, you can just go and calculate the ones that are required in the final calculation. And you can see that the calculations simplify and one of them becomes 0 and hence the other one becomes the right answer. Now there is one place where students confuse. Here I just want to mention that the values are the same across the features. Now for outlook and humidity and temperature, there are different possible values for each of these features, right? Outlook can be either overcast or sunny, and then there could be humidity, which is high or low, and so on. But here, the values for these different features are all in A, B, and C. And sometimes what students do when they do this calculation is they calculate this like a text document where they calculate the number of A's where there are pluses, like three A's where there's positive category out of all the A's in the data set. So that would not be the right way to approach this problem because there are specific features, feature 1, feature 2, and feature 3. So that would only be right with when A itself is a feature. So remember the Chinese, Japanese document example, any text document example, the ones that you did for your homework, the word itself is the feature. Then you count the number of words and that helps you in the calculations. But here F1 is our feature and F1 can take possible values A, B, and C. F2 is a feature, can take possible values A and C. F3 is a feature, can take A, B, and C, right? So now that's why you have to restrict your counts to that particular feature when you are calculating in this problem. And that is one common mistake, and that the overlap in the feature values is given for initiating that confusion, but once you see that these are different features, you can get over that and then finish your calculations correctly.